Let's go.
Okay, so we're going to be dealing with surface area and volume cones. And for the pyramids, you're going to be dealing with what's called a regular pyramid, which means that the base is a regular polygon. It means it's a square, equilateral triangle, regular pentagon, regular hexagon, something along those lines. Okay, and there's some special pieces to the pyramid, and one of them is called a slant height. And the slant height is the height of the lateral face. You know, this triangle right here, which is actually isosceles triangle. It has a slant height. The two edges act as the legs, and then this red piece right here goes from the vertex perpendicular to the base. Okay, and so this red piece is called the slant height. It's how tall this lateral face is. Okay, now some other things happen in here, and some of them you'll use and some of them you won't use. But of course you have your height or your altitude, right? It goes to the center. Now, look what happens if I put this piece of paper here. We've got your height, which is the gold. We have the slant height, which is the red. And then if we look at the distance from the center to the edge, which is like half the length of the edge, it creates a right triangle. See that? Okay. So you might have to use Pythagorean theorem to find something that you need. Okay. We also get another one if we use the base edge and the height, and then the segment that goes from the center to the vertex. That's like the radius of the circle, the circle, right? So we get another little right triangle right there. Okay. So we get two right triangles that are actually inside our pyramid. It happens at the cone also. Okay. And so to find the lateral area of a regular pyramid, we take half the perimeter of the base times the slant height. So half the perimeter of the base times the slant height. And then for the total surface area, you take that lateral area and then you have one base. So you add the area of one base too. Okay? So those are the two formulas that we are going to deal with for surface area. Okay, so let's look at this one. Okay, they want us to find the lateral and the total. Okay, so lateral, remember, is half the perimeter of the base times the slant height. Now, it says it's a regular pyramid. You're telling me this is what shape the bottom. It's a square. One of the base edges is 4, so that makes the perimeter what? 16. So it is half the perimeter, which is 16, and then what's my slant height? 7. So I end up with 8 times 7, which is 56 centimeters squared. So that's the lateral. Then I need to find the area of the base, which again is a square. So what's the area of the base going to be? The area of the base is going to be 16. So then my total is the lateral plus the area of the base. So that's 56 plus 16, which is 72 centimeters squared. Okay. All right, here's another one. We want to find the surface area of the regular pyramid. Now, it looks like the base is a hexagon. Okay? All right. So we want the lateral, which is half the perimeter of the base times the slant height. Okay? Now, the base edge is 4. It's a hexagon, so what's the perimeter? 24. Okay? So that would be half of 24, and then times the slant height, which is what? 12. So that ends up being 144 inches squared. Okay, now I need the area of the base. This is probably the hardest part of this whole problem. Okay, remember that my base is that regular hexagon, so I have to use half perimeter times the pocket. Now we already know the perimeter, right? It's 24. We found that a while ago. But we've got to figure out what the pocket is. So go back to our last chapter that we talked about area. Remember, we had to find the measure of the central angle. What's the measure of the central angle? 360 divided by 6, which is 60. Okay, so it's 60. All right, then we're going to drop that approximate. Okay, and what does it do to that 60-degree angle? It bisects it into 30, right? So now what we have is a 30-degree angle here. It also bisects that base edge, which makes it 2, right? This is going to be 60 is 2 radical 3. Alright? So I end up with 24 radical 3 for the area of my base. Right? Half 24 is 12 times 2 is 24. So then my total is the lateral, which is 144, plus the area of my base, which is 24 radical 3. So I have 144 plus 24 radical 3, and I end up with 185.6. Now, probably most of the ones that you will do, I will give you the Hoffman and the Bricker, or the side link. But there might be one or two where you have to actually find it, okay? Okay, now let's talk about a cone. Was there any questions on that? Okay, now let's talk about a cone. Okay, a cone, remember, has a circular base, okay? You have, just like with the cylinder, it has an axis. The axis goes from the vertex to the center of the circle. In a right cone, which is what we'll primarily work with, not all of it, but most of it, it also is the height, the altitude. Okay. There is an oblique cone, and that is where basically the altitude and the axis are different. Okay, but it still has an altitude. Okay, it's just kind of slant, right? The altitude doesn't go to the middle; it just kind of goes off to the side. Okay. All right, and then it also has a slant height. Okay, and it goes from the vertex to the base edge. Okay, and just like with the pyramid, there's a little right triangle created inside the cone. So if you look at the altitude, which is the gold, the slant height, red, and then the radius, then that makes the right triangle. You might have to use that to find something. Okay. All right. So let's look at the formula. The formula for a right cone is pi times the radius times the slant height. Okay. Which is basically half the circumference, right? So pi times the radius times the slant height. And then the total is the lateral plus 1 base, just like the pyramid. Okay. All right. So in this problem here, we're going to find our lateral, and it is pi times the radius times the slant height. What's missing here? The slant height. So what's going on right here? I got a 30, 60, 90-degree triangle. What do I have? Short, long, or hypotenuse? Cross the 30, so it's the short. So I need the hypotenuse, which is going to be. Okay. Remember the 30, 60, 90. Okay, if this is 30, that's my x. My 60 is x radical 3, and my hypotenuse is 2x. Okay, so if my short is 5, my hypotenuse is 10. Alright, which is my slant height. Alright, so I'm going to do pi times the radius, which is 5, times the slant height, which is 10. So that ends up being 50 pi. Now, it may ask you for the lateral rounded to the nearest tenth, so you would actually do that. But when we go to find the total, you want to go back and use that in terms of type exactly. So then we need the area of the base. The base has a radius of 5, so what's the area of the base? 25 pi. So then my total is the lateral, which is 50 pi, plus the area of the base, which is 25 pi, at 75 pi. So if I plug that in, I end up with 235.6. Slant height is 10. So that's pi times the radius, which is 5, times the slant height is 10. Oh, first, no, that, no. Well, this is radius squared for the area of the base, but not for the slant height. Equilateral. Okay. All right, here's another one. Okay, what's missing in this one? Huh? The slant height is missing. Well, 4, 5, and then what's the multiplier? So 3 times 4, 4 times 4, so this would be 5 times 4, which is 20. Okay? So then the lateral is pi times the radius times the slant height. So that's pi times 12 times 20, which is, what, 240 pi? Then we need the area of the base. What's the area of the base going to be? Radius is 12. The area of the base is going to be 144 pi, right? And so then my total would be my lateral, which is 240 pi, plus the area of my base, which is 144 pi. So that's what, 384 pi. So 384 pi, 1,206, 0.4, 1,206. 0.4. Alright, so my total surface area is 1,206.4. So that's surface area, okay? Now we're going to talk about volume. Now, the volume formula is pretty easy. It's easier than surface area, I think. The thing about it is you got to take a third. Okay, you got to remember to divide by 3, and I always forget to divide by 3, so remember, okay? So the volume of a pyramid is a third the area of the base times the height, not the slant height, it's the height, okay? So a third the area of the base times the height. So I was just making a classroom model of the food guide pyramid for a class presentation. The model is a square pyramid with a base edge of 12 and a height of 15. Find the volume of the plaster needed to make the model. Okay. So we have 1/3 the area of the base. The base is a square base, so the area would be what? 144 times the height, which is 15. So we end up with 5 times 144, 720 inches cubed. Volumes in cubic units. Okay, volume is in cubic. Because the base is the square, the base edge is 12, so 12 times 12 is 1. It's a regular pyramid. Okay. The volume of the cone is very similar. It's also a third the area of the base times the height. Sometimes people write it 1/3 and then just pi r squared times the height because that area of the base is always a circle. Okay, that's just more of an extended version of the formula. Okay, so on this one, find the volume of the cone. I think we have everything that we need, don't we? We have the radius and we have the height, right? We don't need the slanted height for volume, do we? No. Okay, so we could do 1/3, and then what's the area of my base?
25 pi.
25 pi times the height, which is 12. Okay, so that ends up being 100 pi, which is 314. 100 times pi, 314 centimeters. Okay, what about this one? This one we have the height, but what's missing? We're missing the radius, right? So we need this, and yes, we are going to use this tangent, right? But should we use this 48-degree angle, or should I use its complement? I would probably use its complement, which is what, 42? Because that's what the radius is on top. Okay, so this is tangent opposite over adjacent. So I would do the tangent of 42 equals the opposite r over the adjacent 10. Multiply both sides by 10, so my radius is 10 tangent of 42. Okay, so now I want to find the volume of the cone. So that is 1/3 pi times the radius squared. That's 10 tangent of 42 squared. and then times the height, which is 10. So probably if I were to plug it into my calculator, I would go ahead and type in 10 tangent of 42 and hit enter, and then square it. And then I would multiply it by 10 pi, and then do what? What I tell you can't ever forget to do. Divide by 3. So you get 848, 849 actually. Any questions on what I did there? Huh? Yeah, I would hit enter though. 10 tangent of 42, enter, and then square it. When you can put parentheses around it, but you're going to have to double the parentheses. And then times it by 10 pi, and then divide by 3. Huh? 10 tangent 42. Okay, yeah. Okay, I told you. That's it. So up here. Alright, so 10 tangent 42. Make that in. Then square it. Okay, then multiply it by 10 pi, and then divide by 3. Okay. Well, you could do it with parentheses and stuff, but you didn't have enough parentheses to do what you were doing.
I'm doing that, but I keep getting 5,498.
Where would you divide by 3? Okay. Now, here's the volume of an oblique cone. Okay? You still do surface area of the base times the height. Doesn't change. Surface area is different, but volume still uses the same formula. Okay? Now, they've given me this length right here. It's a 45, 4590. I don't have the height, and I don't have the diameter. Right? So, can I find that?
Yes.
Okay, so what do I do? Remember, 40.
Divide by radical 2.
Okay, you got to divide by radical 2. So you take 16 equals x radical 2, divide by radical 2. You can't have a radical in the denominator, so you end up with 16 radical 2 over 2, which is 8 radical 2. So both of these are 8 radical 2, but I don't need the whole diameter. What do I need? The radius. So divide that by 2. So the radius is 4 radical 2. Okay? So my volume is 1/3 pi times the radius squared. What happens when I square 4 radical 2? 16 times 2, which is 32, right? So times 32, and then times the height, which is what? 8 radical 2. Okay, so I'm going to put 8 radical 2 in first, and then times 32 pi, and then what do you got to do? Divided by 3. 379.1. Okay. Explain the similarities and differences between surface area and volume. Okay, surface area is what covers the outside of the shape. I think of it as everything that's exposed to air. That's what you got to cover with surface area. So you got to find the area of all those parts. It is also in square units. Volume is what? How is it different? It's the inside. What fills up the inside, and it's measured in what kind of unit? Cubic units. Okay. All right. So this is the last one I want to do. There is one correction. I changed this right number here. It's set at 9. Okay. Now this is a composite figure. We want the surface area and the volume. All right. So when we're dealing with this, okay, we have a prism and we have a sphere. Surface area is very trickier than volume. Volume is time both volumes now together. Surface area is just what's exposed to air. So in the pyramid, I only want the lateral faces. I want the lateral surface area because this is not shown, right? I'm not going to cover that up. And then with the prism, I want the lateral and one base. So I got to do the lateral of the pyramid, the lateral of the prism in one base. Okay? Alright. So we have the lateral for the pyramid. And that is what? Half the perimeter of the base times the slant height, right? Okay. Now my problem is that I don't have my slant height. Okay? I do have that right triangle that's inside. So if I draw this down to the middle, and then I come out to the side of the edge, and then my slant height drops down. Okay? Now, the height of the prism is 8. The height of the whole figure is 20. So what does that leave for the height of the pyramid? That leaves 12 for that, right? Now, this goes, since this is a right pyramid, it goes to the middle and out. This is 10 right here, so what does it make this? Makes this 5, right? And so this is a right triangle, this is 5, this is 12. What's the slant height going to be? The slant height is going to be 13, okay? Nice. Okay? So, if half the perimeter, what's my perimeter going to be? 40. 10 times 4 is 40, times the slant height, which is 13. So I have 20 times 13, which is what, 260 feet squared, right? 260 feet squared for the lateral for the pyramid. Then I need the lateral for the prism. Why would you even go ahead and find the bottom? You're supposed to track that gets not. Okay, so, alright, so from the lateral of the prism, it's the perimeter times the height, right? Perimeter times the height, and say the perimeter was 40, right? And what's the height? 8. So that's what, 320. And then we need the area of just one base, right? And it's a square. So what's the area of the base? 100. So we're going to take for the total, we're going to take 260, which is the lateral of the pyramid, plus 320, which is the lateral of the prism, plus the one base. So what is that? 580? 680? Is that what you guys got? 680 feet. How did I get 40? Because these are all 10. I told you to change this to a 10. These are all 10, so 10 times 4 is 40. That's perimeter. Because this is going to all be the same up here also. Okay? Because they're the same size. Does that make sense? Huh? Yes? Huh? Well, we are, but it's not the same base as the prism. Okay? It's a square. They sit on top of each other. Right? So the base of this is the same as the base of this. Right? So if this is 10 all the way around, then this is going to be 10 all the way around. So with the lateral, you get the perimeter of the base of the pyramid and times the slant height divided by 2. Okay? Alright, now volume of the pyramid. That one's pretty easy. Okay? That's 1/3 area of the base times the height. Okay, what's the area of the base? The area of the base is 100, and the height is, the whole thing is 20, but the height of the pyramid is 12. Okay? So that ends up being 400 feet cubed. Then we want the volume of the prism, and that's just length times width times height, right? So that's 10 times 10 times 8, which is 800 cubic feet. So then the total volume is 400 plus 800, which is 1,200 cubic feet. Alright, any questions? I know that's a lot. Honestly, it's formulas. So, if you got the formula, should be able to do it.